Friday Plus Plus is a new initiative from Techies that we are starting from today. The objective is to deep dive into some of the most happening technologies. We will seek to understand the implications of these technologies for companies, for engineers and technologists, and for India. We will look at the implications for government policy. The first series is on the electronics and semiconductor ecosystem, and we are doing this in partnership with Siemens. I'm Sujit John, and I have with me my colleague Shilpa Fadnis. The two of us will moderate the discussion. The electronics and semiconductor industry is the talk of the world today. You can see some pictures there on your screen now. Number of electronic products, including cars, are today, I'm calling cars an electronic product because that is what it's becoming. These are in short supply right now because semiconductors are in short supply. The US, China, Europe are all making massive investments in electronics and semiconductors, partly in an effort to become more self-reliant because these have become such core technology in all of our lives. You can see what happened in 1956. That's an IBM RAMAC. It's a storage capacity of 250 bytes, cost $10,000 at that time for per megabyte. On the right, you have a 1 TB micro SD card today. It costs just 17,000 rupees per terabyte. 1.7 paise per megabyte versus $10,000 per megabyte in 1956. That's the kind of changes that the industry has seen. Today, we'll discuss how everything around us is becoming intelligent, how our lives are being transformed by electronics, and we'll discuss the underlying technologies. For this, we have with us two veterans of the semiconductor industry. We have Ruchir Dixit. Ruchir is the country manager at Siemens EDA. Ruchir came to Siemens when Siemens acquired Mentor Graphics. So Ruchir has practically been with Mentor Graphics for 22 years now. For about half of that period, he was in the US. Ruchir is also the treasurer and executive council member of IESA, the India Electronics and Semiconductor Association. In all these years, Ruchir has either directly worked on or worked with customers on over 200 IC tapeouts. After spending close to 10 years in IC development roles, Ruchir moved into EDA, Electronic Design Automation. In these roles, Ruchir has worked with many customers worldwide and helped them to define the problem and then work to create solutions. Welcome, Ruchir.
Thank you so much, Sujit. It's a pleasure.
And we have Vivek Yagi. Vivek is GM and Business Unit Head at Rashi Peripherals. He's also the Vice Chairman of India Electronics Semiconductor Industry. Vivek has over 25 years of experience across major companies, including Western Digital, SanDisk, Motorola, Freescale Semiconductor, and Philips. Vivek started the sales operations for SanDisk OEM and enterprise business in India in 2014, and later led the Southeast Asia and Australia and New Zealand regions too. Vivek has worked in automotive electronics, industrial telecommunications, data centers, servers, storage, and IoT. He's currently creating a new business unit at RP Tech that will distribute semiconductors and components for embedded applications. Welcome, Vivek.
Thank you, Shilpa. Pleasure to be here.
Those of you who are viewing this can send the questions through the comment section. We'll put them to Ruchir and Vivek. Ruchir, coming to you, the world is today obsessed with electronics and semiconductors. Governments are investing billions of dollars into it. If you can tell us the excitement in the space.
Okay, so before we talk of the government investments, I think it's important for us to understand what's causing this excitement. You use the word excitement. When we look around us, within 30 seconds, whatever our eyes fall on will have something electronic in it. Whether it's something that we are using to telecast this event, the number of electronic devices that are part of this ecosystem to get my voice to the audience, or the simplest thing like a light bulb in the house. Those are the things that we see and feel because these are on the consumer side. There are a lot of things that we don't see are also causing a huge demand in electronics. Simple example I'll give, which is sometimes not visible. Some of you who are non-vegetarian and love to eat shrimp or prawns, you might not know that the shrimp farms on the eastern coast of India near Vizag are using electronic devices to maintain the acidity, the food supply for the shrimp in the water using electronic devices. So the farmers no longer have to go into the water and test every single day. It's happening the same way in logistics. 90% of our logistics, whenever we order from Amazon, all we see is order placed, paid through some platform, and automatically the shipment arrives in a couple of days. Everything, the packaging, the selection, the inventory management is all dependent on electronics. Then there is the other side, the industrial automation. Everything that we use today is produced today by using electronic components and electronically controlled machines, whether it's a car or the cell phone. Now, coming to the government side, Shilpa, governments have started to now realize that the century of oil is coming to its end. And what we are starting now is the century of electronics. And this has become such an important issue that governments have also started to realize that this can be of strategic importance to countries. So now governments are thinking about what is our dependence on electronics, how much can we produce locally, how much do we need to depend on somebody else. And then in addition to that, there are some applications where governments want to maintain their control. For example, space and defense. So all of these things are coming together as we live through this time now, and all contributing to this huge demand of electronics. And we can also talk about why we have the demand for this electronics. Why does it need to be digitalized? But I'm just trying to draw a big level picture of why all of this is combining, how this is combining. And that's what's driving us today.
Okay, century of electronics. Vivek, you want to add to that? Enormous excitement.
Yes, absolutely. I just wanted to narrate a news item I read in month of June in an international publication that shows the strategic importance of semiconductor in today's world. So all of us know that Taiwan is a powerhouse in semiconductor manufacturing. One world's largest foundry company is based in Taiwan. And Taiwan was largely not so affected by pandemic in the first 1 year, but starting March, April this year, they had a COVID spread and they were struggling to get vaccines. This is what the news article said. They were struggling to get vaccines, and due to geopolitical issues in their neighborhood, they were not getting vaccines. At the same time, what I heard is that German government reached out to Taiwanese government that all our car factories are shut because of shortage of semiconductors. Can you help us to get some priority on shipping some semiconductor devices to keep those premium car factories running? And these guys pulled in, of course, the largest foundry folks on the call. And those guys said, our government and our country is struggling with COVID vaccines. If we help you, can you help us in return? And then the deal for 5 million vaccines was stuck between them and this. I mean, it's interesting story I read, so I thought I'll just bring it up. You know, it is so strategic today. Besides all the other things that Ruchir said, you know, defense and all the digitalization, etc. So yes, it's very important. And particularly, you know, in the COVID year, we saw how we were all stuck at home. It was work from home, schooling from home, and everything from home. And now we are doing webinars, seminar, conferences, events from home, right? So in these times, the demand for electronic gadgets such as laptops, smartphone, tablets really went up. Otherwise, if you see, laptops were pretty much a stagnant market for last 10 years globally, right? Smartphone was, of course, growing, but laptops were a stagnant market. But laptop market grew 20%, roughly 20%, 19 to 20% worldwide. That's a huge jump, right? Similarly, smartphone. So in COVID times, when the COVID stuck, most companies actually curtailed their investment in capacity, thinking uncertainties around the world. But at the same time, the situations came such that demand for all the same gadgets went up by 20%. So on one side, you didn't invest that 10, 15% that companies are investing every year to expand the capacity and, you know, support the regular growth of a high single digit in this market. On the other side, demand went up in double digits. So I think that double whammy caused a lot of shortages in the last 18 months.
Yeah, that's right. I mean, cars also today, I mean, huge waiting queues for months. And I guess it's all cars themselves are becoming extremely electronic products at the end of the day. How many semiconductors go into a car now? Any estimate of that?
How many, you know, go ahead, Vivek, you started.
Sorry. It could be anywhere, it depends on the car. You're talking about $10,000 car or $100,000 car. It could be anywhere from 50 to 100 semiconductor devices all the way up to 1,000 semiconductor devices.
Wow.
Yeah, it depends on the level of the car. And, while semiconductor were hardly any part of bill of material in the past, but they're becoming a significant part of bill of material of car. And also, I want to highlight, Sujit, that as cars move from internal combustion engine to electric in the future, the role and the content of semiconductor is further dramatically going up inside the car.
Yes. So, since we're talking cars, and we're talking of cars because these are the big objects that are very visible, and it makes big news. So, Vivek talked about internal combustion to EV move. Just looking at the internal combustion today, we talked about, okay, 10,000 semiconductor parts or electronic parts can be in the system. Another way to look at it is how much wiring does a BMW 5 Series have today? If you were to lay down all the wires that are in the BMW car today, end to end, it's about 5 kilometers. And this 5 kilometers of copper wire is connecting all the devices in the car. And these are not necessarily smart features. These are features to turn the blinkers on. These are the features to turn rain sensing wipers on. These are the features to turn headlights on when the ambient light goes down. Infotainment. So even for the basic, or what we can today call some of the basic functions, there is a lot of electronics. As we transition over to smart cars, autonomous cars, EVs, this is only going to go up. And then coming back to the shortage part, the shortage is everywhere. It's just that autos make bigger noise, but any semiconductor supplier today or any system supplier today, if you go and talk to them, they are now looking at anywhere from 40 to 50 weeks of lead time, which used to be 2 to 3 weeks of lead time. Simple things like, some of the products that we sell, we make appliances and we sell in the market. We were running at 3-week lead times. We are now being told 36-week lead time. So having said that, in the past 6 months or so, situation has improved. It will take another 6 to 9 months for us to come back to what it used to be pre-COVID and this whole shortage. But again, it underlines the demand and our dependence on electronics in every facet of our life.
We saw those pictures of the Bionic Man and Iron Man and all that, virtual retinal displays. Tell me, where are we going to get to? What are some of these technologies, innovations that have been spurred by semiconductors that might be still in their early stages, but which you think will touch billions of lives in the coming decades? Can you visualize a few?
Okay, before we start looking at the physical manifestation of devices, there are things that are affecting billions of lives because of electronics even today, right now. We all have streaming platforms like Netflix or Prime or Sony Live or whatever. All of these are using machine learning to come up with suggestions on what they think we will like. And more often than not, we end up choosing selections that they put for us on the screen. So machine learning is something that is going to drive the applications forward and the use forward. Now, if we dig a level down, why machine learning? Machine learning, because fundamentally, if we look at our evolution, we've always worked really, really hard to make our lives easier, which is kind of dichotomous in nature, right? All of us have worked really hard to make our life easier so that we can become lazy eventually. But the driving factor for that is, can I get something that can make decisions for me? Can I get some help to do certain things for me? And as we look out into the future, more and more applications will be driven by machine learning. We saw the Bionic Man. It is essentially a piece of machinery that will be controlled by learnings of itself and learnings of the past to drive what the next behavior should be. And that's the essence of machine learning. Right? Today, we are seeing it more on the things that we consume. And we talk of, sorry, I'm going into this machine learning thing, but I think that this will come up anyway later at some point. Today, if we look at machine learning and AI, we are right now in the modeling phase of machine learning, where we create a model, and based on that, we say what we can predict may happen in the future. In the next 5 to 10 years, we will get into the inference advantage of machine learning, where we will depend more and more on these machines to make decisions for us. Not just give us data, not just give us a prediction, but make a decision for us. The first application that will come into the market that people will start to experience is an autonomous car, in my opinion, because the car will have to decide whether the thing that it sees on the road is a shadow or a real dog. And based on that, it will have to make that decision. Can we get to a point where each one of us is walking in a bodysuit? I think we are already getting there. If you look at some elite athletes, the number of things that they have on their sports jerseys, things that are monitoring their heart rate, things that are monitoring their breathing patterns, things that are monitoring their oxygen levels while they're performing in the sport on the field, is already happening today. Yes, it's happening.
There.
It's already there. It's just invisible to us, and it's not very ubiquitous, but it's out there. The ability to help a person who has vision difficulties, to give them that ability to sense the world around them through an electronic device already exists. Now, it's not to the same level that it will be in 100 years, but we are already getting there.
Okay. Vivek, you want to add to that?
Yes, so as Ruchir said, artificial intelligence followed by machine learning, I think this is becoming extremely important. It's also opening up new areas of industrial revolution, such as Industry 4.0, that is being referred to as, industrial automation. So previously, all this smartness, digitization was more related to, the IT environment. But now, with the 5G coming up as well as AI coming up, you can add to a lot more industrial, intelligence. So I'll give you a simple example to understand. So the modern e-commerce companies are building very massive fulfillment centers or warehouses, right? In those massive warehouses, and they're receiving hundreds of orders per minute, right? So it's manually, it's almost impossible to pick invoice and then go to different shelves. The warehouses are sometimes a kilometer long, and pick the right item without any error and bring it to the invoicing and dispatch point. So a product robots like AGVs or automated guided vehicles are being developed today as part of Industry 4.0, which have multiple high resolution cameras, and only with AI, algorithms running on that vision based feed that's coming in, they are able to figure out exact location of the item that's to be picked and go exactly over there at the high speed, pick it up and bring it over there. So this is an example of industrial automation I just wanted to highlight. It's really fascinating if you go into one of these fulfillment center to see how this AI ML is actually working there, right? Okay. Besides that, I think for all of us who use mobile phones or use iPhone, we speak to phone and phone searches things for us on the web. It's a simple example of artificial intelligence or machine learning. And if you see the phones a couple of years back, especially I was an iPhone user, when initially this talking to phone and asking for things was not working very well in India with Indian accent. But as you start talking again and again, they start to understand your accent and perfect it, right? And now it works very well for me. So that's example of machine learning slowly your accent and then, perfecting its work. So yes, absolutely. This is the way to go in the future.
Okay. And in the semiconductor itself, there's a lot of specialization now happening to create chips and all that, that work particularly well with AI ML, right? Google,
yes,
Intel, Apple, everybody seems to be kind of working on these kinds of chips.
Absolutely, yes. And if we look at machine learning, the primary backbone of machine learning is first we got to capture data, then we got to transport data, and then we've got to process the data, and then we got to send the decision back to the point where the data was captured. Right? So these are the four fundamentals on which machine learning works. So each of these areas is highly specialized, and we want each of these areas to be as fast as possible with the fewest watts of power that is spent to do this whole circle. And I go back to the autonomous car that I talked about. And this is real data. If an autonomous car is driving on the road, and if it sees a potential obstacle, the car has 13 milliseconds to understand what it is and make a decision on whether it needs to apply the brakes or not. So all of this needs to happen in 13 milliseconds. In that, it also needs to make sure whether the road is slippery because of rain, if the visibility is fine, and will the dog move out and it doesn't need to stop. So what ends up happening is that we will need specialized hardware for solving each of these pieces along the value chain. We need to have really fast and accurate image capture, different ways, simple cameras to LiDARs, radars, and all those things, combining all these together. A very fast way to transport the data, very fast way to compute it, and a very fast way to send it back. And no single semiconductor device can do all of these at its perfect level required. So that's where specialization comes in.
Okay.
Now, this is just one example, but in every field, these specializations are required. Right today, another example I'll give. Right, I am using a Bluetooth headset to talk to you and the rest of our audience. Some of you are using built-in microphones in your machine. Some may have an external microphone which is wired. All these are very different mechanisms to get my voice across from me to you. One cannot do the job.
All of them require different kinds of
all of them require
chips.
different kinds of chips, different kinds of algorithms, different kinds of processing. The input and output might be the same, but the medium that it travels on is different, and therefore it creates a need for separation and differentiation.
Fascinating.
So I just wanted to ask you, Ruchir, and Vivek can also chime in. Chips are getting more powerful and smaller. Is miniaturization reaching its limit? What are the options available going ahead?
Yeah, Shilpa. So I think all the techies maybe in this seminar have heard or known or practiced something called Moore's Law. So Gordon Moore was a scientist or engineer at Intel, and he coined this Moore's Law, saying that roughly every 2 years the number of transistors on a chip will double, thereby doubling its capability. So this loosely said principle has guided the industry till now, and it might continue to guide for some more time. So traditionally in the computer CPUs, they kept on increasing the number of transistors, so they increase the capability in terms of clock frequency, and also try to reduce the power, etc. And then whole idea of Moore's law was to shrink the geometry or the size or dimension of the real estate, so that your cost also goes down, because silicon is made on a standard 12-inch silicon wafer. So more dies you can carve out of the same real estate, the cheaper it becomes. It's like earlier we had independent houses in the plot of land. As more people came to the city, we started to build apartments. So in the same square feet you can pack more people basically, and thereby reduce the cost of housing or cost of silicon real estate per square millimeter much lower. That's the whole idea of Moore's law. So yes, as you said, as we continue to shrink this, eventually we'll reach a point where by nature of physics you're no longer able to make it smaller, because the lithographic equipment are no longer able to etch the circuits on those dies, because everything has become so small. If you reach the size of electron, which is the basic current carrying unit, then how do you do it further? So industry has already from last few years figured out some other alternate ways to improve, reduce power, improve efficiency, or improve performance. So one way to do this is, of course, keep shrinking the real estate. There are other ways. So traditionally, they were homogeneous processor architectures. That means you have one CPU core, you keep adding more CPU cores. So that's parallelism. So that's one way to improve the performance and reduce the power. Now, in last couple of years, they are heterogeneous processor architectures. That means you not only make more number of cores, but you start adding very small, low-cost, specialized cores to do other tasks. For example, in a processor, security is also important. So security is made it as a silicon chip or as an intellectual property added to it. So similarly, you keep adding more things to it, or you add more amount of cache inside to improve the performance. Number of things. Now, previously, I also worked with a flash memory company, and what flash memory industry figured out by 2015 was that shrinking the geometries below 15 nanometer is going to be very expensive for them and not worthwhile to reduce the cost further. So instead of, shrinking the die, they actually went back to a slightly bigger die, but they started to put these dies one on top of each other. Again, I'll give the example of making, high-rise apartments. Still, the integrated circuit that we manufacture and ship has enough thickness to take so many stacks of, these dies. So they start with the 24 layer dies, and today flash industry is shipping, 160 layer die, or even they're talking about 196 layers of die stacked on one on top of other. So this is innovation in packaging, not necessarily in the shrinking. So there are different ways technologists has.
Is this what is called 3D packaging?
This is called 3D packaging. Absolutely. Yeah.
Okay.
So there are a number of variety of innovations that industry has now figured out to go around the Moore's law and improve the performance and density and reduce the power using other techniques other than just shrinking the same die.
So, Vivek, you talked of Moore's law, and there's been talk of Moore's law dying for the last 15 years that I have memory of. And I just want to point out that while we talk of Moore's law and the impending death of Moore's law as the death of the world, we just need to go back and see how the industry has changed over time. This is not the first time that the industry has hit a road bump where people thought, okay, now what do we do? Right. So if we go back, let's say 1980s, prior to that and way before my time, and you did talk about that I have been with Mentor forever, which is true, but it's not been forever. The circuits were simple enough that people actually drew the circuits on paper. They would take different colored markers and create the circuit on paper, and then that was fabricated. As circuits started to become a little bit more complicated, this pen and paper method just wasn't sufficient. They needed something else. And that was the time when EDA started to come to the scene. Mid 1980s is when some of the first EDA companies appeared on the scene. And they started helping the engineers design more complex circuits that were impossible to be done by hand on pen and paper. That went on for a decade or so. Then industries realized that, hey, EDA and automation and all of this is good, but the productivity that I need to meet the consumer demand is not there. It shouldn't take me 3 years, 4 years to design everything from scratch and get it into the hands of the customer. So what do we do? So then industry came up with IP reuse concepts and all standards around how an IP can be created in-house and used in the project inside, or it can be supplied to somebody outside. So IP reuse became the norm, and that's what gave the next step function to the growth of electronics. When that was going on, Intel came out with the most famous marketing campaign, I believe, ever, Pentium, because although it is almost 35 years old, people still remember the name. And at that time, if some of you are as old as I am, you'll remember the talk was always about what's the clock speed? How many gigahertz? Right? Every version from 1 gigahertz, 1.2 gigahertz, now we are 1.8 gigahertz. But eventually that speed also started to get saturated. But we wanted more. And that became the roadblock. So then what did we do? Something that Vivek just mentioned a little bit earlier, we introduced parallelism. We have multiple CPUs, things getting done in parallel. So that was the next step. We implemented that. And then on the other hand, what started to happen was now the compute from the server to the desktop started to become smaller and started to come into the hands of the consumer. We're talking of laptops, we're talking of cell phones. And suddenly power became an important factor, which in the past was not that big a factor. We don't want a phone burning in the hands of the consumer. So then a new transistor architecture was created, the FinFET, which is what it's called. The FinFET was created. And that allowed us to go from 60 nanometers to what we are now approaching, and you're talking of 5 nanometers, 3 nanometers, and all of that. So we have overcome roadblocks before. This new one is yet another roadblock. You and Vivek both talked about 3D IC. Then there are other materials. Why limit ourselves to silicon only? There is graphene, there is silicon germanium, and there are many other materials now that we can talk about that will help us get to the objective. Because remember, Moore's law was talking about putting more transistors into per square unit of area. Inherently, it is talking about the amount of compute power that you have in per unit of area. So we still can get the same levels of acceleration and increase in the compute and performance power without having the need to keep shrinking it down to the atom or the electron level. 3D IC is definitely one of them. And then 3D IC is also, I think, something that we should, I'll just spend a couple of seconds on it. There are 3D is 3D packaging and 3D IC. And they are two slightly different concepts. Packaging is essentially taking two dies, or you do system on package that Vivek was talking about initially. You take two devices, put them on top, and you connect them through wires. 3D IC is much more advanced than that because that needs to be taken care of at the time of first level fabrication of the circuit. So a lot of work is going on, and yes, Moore's law, we will not be able to pack transistors in per square inch, but we will be able to pack transistors in per cubic inch. So we're now going into the Z direction, and that will help us get the performance that we need. Parallelism will get us the performance that we need. Another area which will help us in making very fast interconnects, getting a signal from point A to point B, is silicon photonics, using light instead of current to drive information. So all of these things will emerge. We will have a period where we will have all of these technologies coexist. And eventually one of them will prove to be the one that is economically viable and still gives us what we need.
So we have a long way runway. I mean, it's not going to stop anytime soon. There are plenty of experiments going on.
Plenty of experiments going on, and the history of mankind tells us, Sujit, that we won't stop.
Yeah, how are 5G and IoT enabling newer technologies, and what are the possibilities that you see going forward, which we haven't seen before, right?
5G, IoT.
5G, IoT. So let me separate these two out first. IoT is Internet of Things, and I actually prefer to use as Internet of Everything. And Internet of Everything, it comes down to something that I had talked about earlier, the ability to capture data, transfer data, process it, and transfer it back. So every device that we will see and are already starting to see today has some ability to capture data. Whether it's a smartwatch that we wear on our wrist, which is capturing our heart rate, which is capturing our sleep patterns, or our phones, where we take pictures and upload them on Instagram or Snapchat. This is where we capture information. 5G is a method to transport that data very, very quickly to the destination. So one depends on the other, because if we just capture data but do not have the ability to transport it, it's useless. If we just have the ability to transport but not capture, the transport layer becomes useless. So both of them are essential. IoT without 5G will not survive. On the other hand, the thing that's happening everywhere is that we are now realizing that sending data from the capture device on a 5G network or on a Wi-Fi network to some other central processing unit, cloud, or a big storage somewhere out in the middle of nowhere, and bringing it back, even that is too slow. So what we will start to see now is more and more intelligence will start to get into the edge devices. I call them edge devices because they're right on the edge where they are capturing the data. My watch, for example, is an edge device. If it's capturing my data on the heart rate data on my wrist, it should be able to calculate whether I need to go see a doctor or everything is fine right here. So we will see that transition happen. But having said that, and Vivek talked about Industry 4.0, that is dependent on a 5G network becoming operational and ubiquitous, because the volume of data that we're going to be moving is phenomenal. Just an example, if you take a modern 737 today, in an 8-hour flight, a 737 captures about 126 petabytes of data. And I don't even know how many zeros petabytes has, but I know it has many, many more than terabytes. So that kind of data is getting collected. So if we don't transfer it, we can't do much with it. So very, very key, interdependent, and will evolve together.
Vivek, let me ask you this question. This has come from Siddharthan A. How does quantum computing fit into the future of electronics?
Yes, that's an interesting question. So again, quantum computing can, it's one way to go around the Moore's law, because Moore's law is implemented in traditional silicon and traditional CPU ways. And if you have to solve some very, very complex problem, like, breaking some high security code, like RSA algorithm is created for security, and breaking it through traditional servers and computers take maybe 20 years, 30 years, because that much amount of calculation needs to be done. So then the traditional silicon-based processors are not able to, work that fast. So quantum computing is still not a commercial thing, but it is under development. But the whole idea is to create, different materials and different level of parallelism there to do the calculations in a much, much, much faster way, so that complex problem like genomic sequencing, which have petabytes or even bigger amount of data, right? Exabytes of data to decode genomic sequencing. Those can be those kind of problem, or weather forecasting related models. Weather forecasting takes into account data of weather in last 50 years at least. And that data runs into hundreds of petabytes or even more. So it's being looked at medical applications or genetic application or those kind of application. Hopefully, in next couple of years, it should start getting more mature and start getting more deployed.
Yep, absolutely right. It's too early. It's a very, very exciting development. It's still in research phase. And I think one of the things that we all, if we see it commercially viable in our lifetimes, is something that we will have to get used to, which is fundamentally different from the electronics today. The electronics today deals in certainties. Either something is on or something is off. Either something is true or something is false. Quantum computing is built on uncertainties. And that's what Vivek was saying, that when there are millions of variables that somebody needs or something needs to bring in to solve a problem, quantum computing is in theory very well suited. Building a real machine that can solve the problem today, that's where we have to wait and see how that all plays out.
Okay.
Right. If you can, Ruchir and Vivek, if you can talk about how India has changed the past decade in electronics and semiconductors, both on demand and supply side, also the underlying policy environment.
So I will just say one thing, Vivek, and then I'll leave it to you, because this is what you are right now currently dealing with in your ISA role. Just to talk about some statistics. I don't know if we realize today in India, we produce 600 cell phones per minute. 10 years back, we were probably producing 6 phones per minute. So that's where the scale of our ability to make things has gone. And just one example. On the consumption side, only on online platforms in India, 160 phones are sold per minute. 10 years back, if you had 160 friends who had a cell phone, that was an achievement. Right? So that's the extremes of what we have seen in the past 10 years. Now, there is a lot of data behind it, and Vivek is currently living that space right now. So I'll let Vivek complete.
Yeah, Ruchir, I think you gave very interesting statistics there. I agree with you. So while India Semiconductor Industry Association did a market research report on semiconductor demand and consumption in India, roughly about 10 years back or 9 years back, I think if I remember right, I think we estimated at that time market between $1 to $1.5 billion for semiconductors in India. And we are now again doing that market research with a third party agency. Data is still not out, but I expect that India to be consuming probably 7 to 8 times of that number in India. So it may be anywhere from 5-6 billion to $8-9 billion range. That's the rough estimate I have. So one is the demand for end electronic equipment has grown dramatically. That's visible to us. So as Ruchir said, cell phone sales online. But to give you the statistics, India is now the second largest market for smartphones in the world. Forget about the basic phone, feature phone. It's anyway converting slowly to smartphone. So China is still the largest market consuming smartphone at about 250 million units. India is consuming 180 to 200 million units. We have overtaken US in last 3-4 years as a biggest smartphone consumption. Same thing with the cars. India is now consuming 2.5 million cars in India, and cars are also consuming semiconductor devices. And it's true with all the other electronics. So it all starts with end product demand. End product demand has grown with the economy and GDP of India growing, right? So consumers are able to afford and desire and buy much more electronics, which is needed to make their life comfortable. The second aspect, so market has grown many-fold in last 10 years to answer one aspect of the question. Other aspect I want to highlight is that the government of India, together with multiple associations like ISA, also studied 5-6 years back the pace at which electronic equipment demand is growing in India. It's mostly getting imported from outside at that time. So a study said that by 2025, the amount of foreign exchange required to import electronics will exceed our oil bill, basically. In the past, you would have seen a lot of news item that India government number one foreign exchange spend is on import of oil, right? But they said the pace at which electronics being consumed, this will exceed even that. So that was a worrisome factor for the government. Hence, the government of India and even Karnataka government and various state government together, discussing with industry association, came out with these PLI schemes, production linked incentive schemes that have been rolled out in last 1 to 2 years. So whole idea was that, if global companies and Indian company decide to set up a manufacturing for electronic gadgets in India and notified electronic item, and if they meet their targets that are submitted to government, then they will get cash incentive. Like we use some of the fintech or Paytm kind of application, we get small cashback as an incentive to continue. Same scheme deployed at a much larger scale. So that has actually pushed a lot of electronic manufacturing, a lot of investment in factories and manufacturing here. All would have seen news that 4 of Apple contract manufacturers set up factories and all the iPhones are getting manufactured here. So I think in last 10 years, landscape, both in terms of consumption, demand, as well as supply through local manufacturing has dramatically changed. And this will continue to happen in next 10 years.
Has it come down to the components level as well?
Yes, a component level as well, because there are certain PLI schemes specifically designed for component so far. Not at the semiconductor manufacturing level yet. Previously, government had invited some bids to set up a semiconductor manufacturing in terms of fabrication unit or fab. But as we all know that fab investment is, $4+5+ billion. And ecosystem around fab is not yet around in our country. But now the government is looking at least, the second phase of manufacturing a semiconductor, which is taking a wafer or a die to assembly and test unit. And when it is outsourced, it is called OSAT, outsourced, assembly and test factory. So there is a serious thinking about it, and we are expecting government to possibly come out with some incentives for global players to come and set up even semiconductor manufacturing. But it may still take a couple of years because large investment and then choosing the right technology node, looking at building the vendor and supplier ecosystem. And again, in that area, Ruchir and I are at ISA, and we are seeing, we are doing a market study on supply chain to semiconductor manufacturing as well. So interesting thing is last year we all saw medical oxygen shortage during the second wave of COVID, right? And then government talked to all the steel plants, especially in eastern part of India, which produce huge amount of oxygen, but it is not a medical grade oxygen, right? But they could tweak their manufacturing, testing, whatever processes, or using some special chemical material to make it medical grade. Same way, what we are looking at here is there are many specialty gases and specialty chemical companies out of India that are supplying things to steel industry, cement industry, pharmaceutical industry. Can they upgrade their product quality to a level which is required by semiconductor manufacturing plants? And even before that manufacturing comes here, these guys become suppliers to global semiconductor manufacturing industry, thereby proving to the world that there is some sort of ecosystem available if somebody comes and set up a factory here. So all these efforts are going on both at associations level, government level, and hopefully manufacturing, we should see even that level of manufacturing in coming years.
Ruchir, we are already very good in design, isn't it? And I'm sure companies like yours are also doing some phenomenal work in India.
Oh, so if again, see, I always, before I talk about what's today and what's the future, I look at what was the past. Our industry started in India essentially back in the early 90s. And there were a couple of companies. TI was one of the first ones. BEL was one of the first public sector enterprise India company, which started doing some design then. And I have seen the evolution of our industry since I moved back here, from moving to following instructions and essentially build to print. Somebody gives you a spec, you design, implement the spec, and you return it. Today, we are at a stage where engineers in our ecosystem are defining products, not just for India, but for the world. They're making decisions on what the product should be. They're making decisions on how it should be done. And that is a huge evolution and a recognition of the expertise that we have been able to build in our country over the last 15 years. If you look at the number of engineers that we have, people close to, and Vivek, you might have this statistic better than me, but around 900,000, 9 lakh people in India are involved in semiconductor design and development of products.
Yeah.
So going 15 years, when I graduated out of college, there were hardly 10 or 20 people who said that I want to make a career in VLSI design, which is what it used to be called then. Now we're talking in electronics design because things are merging. So we have come a long way since then. We have also learned what works for us and what does not work for us. So the way our engineers work is different from the engineers in some other countries. And I'm not talking of work harder, longer, whatever, but we know in India, we have this very famous and our favorite word, jugaad. Essentially what that means is we figure out what works for us in this current situation the best and resolve it and move on to the next challenge. And I think that's what we're getting recognized for. So mindset from the big companies who want to set up an office in India today is about, this is the only place where I can get talent. 15 years back, it was, this is the place where I can get cheap talent. The word cheap has now disappeared from those conversations. So if a company is looking for low cost geographies, in our industry, India does not come up in that map. India comes up on the talent map. There are some other geographies who come on the low cost map. And that's a huge compliment to the audience who's listening today. This is the audience who has got us out of the cheap and low cost map onto the talent map. It's a tribute to them.
Excellent. Is it all software or is there a lot of hardware also involved? What kind of talent are we talking about?
I'm specifically talking of hardware talent, Sujit. People who are designing hardware. So all the comments I made for the hardware talent.
Okay.
Now, on one hand, we have the large low MNCs, Intels, Qualcomms, Broadcoms, Googles, and all of those. And on the other hand, we have lots of Indian companies. We call them fabless design houses or IP houses who don't manufacture themselves, but they are producing designs that go into very, very complex systems. So even the 9 lakh people I talked about, these are hardware.
Hardware people. Okay. Yes. Somewhere people have the impression that China is good in hardware design, etc. India is good in software and all that. No, you're saying
it's a matter of scale, Sujit. I mean, if you look at the number of software, number of software engineers that we have in the country, it is far greater than the number of hardware engineers that we have in the country. Now, each number by itself is fairly large, but relatively number of software engineers is more. I think the comment that people make about China, they also include the jobs that are about assembly. They include that also in there because the factories in Japan employ many, many more people because they have more factories than we have in India. So if you include both of them, then yes, China has more people employed in electronics. But if you just take design, I am pretty sure that we outnumber the design talent from China.
Okay. Shilpa?
We have this audience question. This is coming from both Sachin P and Harsh. What will be the role of India in semiconductor industry 5 years down the line in the global space?
That's an interesting question. There's an aspirational side to it, and there is a real side to it. Funnily enough, those sides are not exclusive. Like I said a little bit earlier, right? Today we have design teams in India who are making decisions for their companies to make a product for the rest of the world. And I believe that this trend is just the beginning. We will continue to go down that path. We will continue to define products. We are talking, last 2-3 years, we're talking of make in India. We will be making in India, but will be making for the world. So that's where I see us going. I see us contributing not just to the design side, but something that we talked about a little bit earlier, also on the manufacturing side. And again, manufacturing is just not wafer manufacturing. There are many things that happen between the sand that is collected to the device, the phone that eventually gets into our hand. So getting somewhere in that value chain is something else that I expect us to do really well, whether it is assembly, whether it is testing, whether it is marking, whether it is packaging. These are some manufacturing components that I see us getting involved in and becoming very, very relevant and a key part of the ecosystem in the next 5 years.
I will just add to that, as Ruchir said, there's a reality and aspiration side. So in reality, of course, the semiconductor design opportunity out of India, the jobs, the demand for skills will continue to grow in next 5 years, even 10 years. And also the electronic manufacturing potential for semiconductor manufacturing, all of that will continue to grow. But my aspiration is that more than all the global companies that are doing this work here, in next 5 years, there'll be some Indian companies or some big Indian business house that will realize the potential of this industry. And they will start investing and creating Indian semiconductor company. That would be my aspirational, thinking for next 5 years for India.
Yes.
And we're also seeing some last press, in last 2-3 months that, Tata is likely to invest in semiconductor business. So we will know soon what's the reality.
So I know the follow-up question to that is, okay, is there something that may prevent us from getting there? You haven't asked that question, but I will ask it on your behalf. So within the discussions that we have with ISA, within the companies and my company, within the customers that I talk to, the number one challenge that all of these design houses, Indian or multinationals, face is a lack of talent. It can be slightly counterintuitive. We have the advantage of population, we have the advantage of engineering colleges, but now it is turning out that the demand for Indian talent is higher than what India can supply today. So as part of ISA and in all individual capacities, each one of us who've been in the industry for a while, we are trying to create programs where we can create talent at a rate which will sustain and grow this industry going forward.
You're partnering with educational institutions and all that for what, more VLSI engineers and things like that?
Yes. That would be the summary. We are partnering with engineering colleges. The devil lies in the details of what the word partnering means. It involves implementing the latest curriculum. It involves, again, when we talk of academia and industry relationships, right? There are two parts to it. There's R&D. People talk about R&D collaboration with the academia. Traditionally, we as an industry and as a country have done very good collaboration on the R side of R&D. What we haven't done as well as we have done in the R is on the D side, the development. And that is when the engineers come out of the college, how skilled are they to become productive sooner in the organization that is absorbing them? Right. So what we are now trying to do is that while the R part of collaboration continues, and of course we will strengthen that because we also want the latest and cutting edge research to happen, but then also focus on the D part of R&D, skilling of the engineers. So there are a lot of announcements that hopefully the industry will make in the next few months, where these kinds of partnerships will take a different shape than what it has in the past.
Okay, yeah, continuing on this thing on India, I mean, there's this question from Nilesh Paldikar. Vivek, you could take that. Are government policies for semiconductors going in the right direction? Do you have any suggestions to improve them?
Yes, it's at least, what I want to say positively is from the industry body, such as IESA, that government is proactively asking questions to semiconductor companies and industry bodies, and they're listening, and accordingly, they're making policy decisions. And PLI is clearly a positive scheme that is born out of such discussion. And we are expecting more such decisions and schemes from the government in, coming time, maybe 6 months, 1 year, which will attract more semiconductor manufacturing related investments, whether it's in a fab or assembly and test has to be seen, which is more viable. But yes, it is certainly moving in the right direction, I would say.
Okay. Okay. Anything specifically that you would want on this platform to tell the government? Do this.
No, we keep talking to government as an industry body, but and one message that is consistent from our side is that consider semiconductor also as a strategic asset for a country. You saw last 1 or 2 years when the US started to put some restrictions on certain other countries, right? That they cannot get certain class of semiconductor, how it impacted those countries, their manufacturing and exports capability. Some of the big brands of cell phones like Huawei, that was almost number 2 years back, is now is not visible at all. And hence it should be understood by government how strategic semiconductor intellectual property or having a fab or having IP and all these companies is for the country, and accordingly start focusing more and more in that direction.
Shilpa?
Yeah, we don't have any audience question yet.
Okay, I have this. I want to ask you this, both of you. And I think Vivek also kind of mentioned it, market research. Steve Jobs once said, "People don't know what they want until you show it to them." So, so what should the aim of technology be? What would you advise to youngsters be? Should you understand customer need states and then build towards that, or build something cutting edge in the anticipation that the end consumer will kind of lap it up?
This is very similar to a quote that is attributed to Henry Ford.
Oh.
If I went and asked my customer what they want, they would have asked me for a faster horse.
Okay.
So it's very similar.
Yeah. I think an iPad kind of was like that, I think. No, I mean, nobody kind of wanted it, but
even the first touchscreen smartphone from Apple was something like that.
Okay.
Before that, we were used to 3310 from Nokia and used to play Snake on it.
So I think there is some truth to what is being attributed to Steve Jobs. There are a lot of situations where the consumer of the product that is being created doesn't know that there is a need. The cars and horse carriages is a perfect example. Until car was envisioned, horse carriages was the thing. Vivek talked about the cell phone. We talk of Apple. Let's go back at the history of Apple. Apple introduced iPod, which created the revival of Apple. But iPod was not the first MP3 player on the market. MP3 players had been in the market for at least 4 or 5 years before iPod came. When the iPhone came, Vivek said that it was not the first touch phone from Apple. It was not even the first touch phone in the market. Touchscreen phones were available before iPhone came around. What Apple was able to do is to create an experience for the consumer. And that experience allowed it to capture the market the way it did. And in a lot of those situations, when we're talking of experience, a lot of times people don't know what the new experience will be. Therefore, they don't know that they need it. We take streaming services. Before streaming services came out, who would have thought that we would be watching movies sitting at home and we would have a library that has thousands of titles at our fingertips? 20 years back, if somebody asked that, hey, do you want a device like that? People might have said no. On the flip side, we have thousands of examples where products were created that nobody wanted. Right? If we go onto the internet, we will see the most ridiculous thing that I saw very recently, at least in my opinion, is a cup that has a battery-operated stirrer built into it. So if you add sugar into it, it'll stir the coffee by itself. Now, to me, it's yes, it's nice, it's funny, but is it a product that will catch the market? So I think a little bit of, I wouldn't use the word clairvoyance, but looking at what the behavior is and what it could be with a level of pragmatism is what a new innovator should be thinking about. And I've been involved with a bunch of startups myself, and the couple of key questions I ask is, okay, if you build a product, can you name one person who will pay you money to buy it? And if you can find that one person, when will you find the 100th person who will pay you money to buy it? And once you found the 100th, when will you get the 1,100,000th person who will pay you money to buy it? And if you cannot come up with an answer for that, maybe there's another time to think about it. Sometimes people just get lucky. I know that also happens, right? So luck also is a factor. Sometimes products get introduced before the market is ready. We talked about EVs, electric vehicles, early in the beginning. The first EV was produced in the 1970s, early 70s. Fully battery operated car was available, a full size car, not a small and a two-seater or one-seater, was available in the 1970s. It didn't take off because it was too early for the market and oil was very cheap. So as a concept, it existed, as a product, it existed, but it hardly sold like 10,000 units over the 10 years, and then it was withdrawn. So timing the market is also very critical. So it's more of an art than science, Sujit, on what you think, what some of the things will be a successful idea, and it actually eventually becoming successful.
Yeah, so I'll just add there that Sujit, I think 80 to 90% of the time, if a company created a product that really solved customers' known issues at an affordable price, is likely to be more successful. But then 10% of the time, it's that great innovation that comes around that nobody has thought about also gets successful. But as Ruchir said, that not all such great innovations have been successful. And some take long time to be successful when, right time arrives for these. Like in 1970s or even in 80s or even in 90s, Chevy Volt from GM was a very good electric car created in US. But there's no charging infrastructure. Charging takes very long time. Battery replacement is a hassle, right? And the range of the car is limited, only for housewives or, moms to drop their kids to school and nothing more than that. It was not there. Then slowly the infrastructure got built around for charging, the range increased, the new battery technologies came. So I think some new innovations take time to mature and then become really popular.
Yeah. The one more thought just came to my mind as I was thinking through it. Any product that is being thought of has to address one of two things. It either needs to solve a problem or it needs to create an experience for the consumer. If it cannot do either one well, or at least one of them very well, it's going to find a hard time to get success in the market. Either solve a problem or give an experience that is unparalleled.
Great. Yeah, I think 5 minutes past our scheduled time. Great discussion. Like you said, Ruchir, at the beginning, I think it's going to be the century of electronics. Your industry is sitting at the core of what the world is today. I think some great experiences are probably going to come out of your industry in the coming years. So thanks a lot. I think fascinating discussion. I'm sure we'll be seeing a lot more of you in the coming days, given what the industry is going to become or is becoming already.
No, thank you so much for this opportunity, Sujit. And Vivek, thank you so much. A very engaging discussion, I must say, because in these times, not having a live audience in front of you and having people to talk to face, it's a very strange experience. But the warmth on this platform that you both brought in was very helpful to get me going. So thank you so much.
Thank you.
Thank you, Ruchir, for inviting me. And thanks to Shilpa and Sujit for their engaging questions. And I hope the audience also enjoyed the discussion.
Sure, it was great fun. Yeah, thank you so much.
Thank you so much.
Thank you.
Okay, bye.
Bye-bye.
Bye.
Bye-bye.